What's going on, fellas? Doing a build tonight for Ken. He is a mushroom grower, I believe, in California, or he produces the grow media for mushrooms. Can't quite remember, but in this build, I need a boiler burner with an extreme amount of power in a very compact space that does not require an air compressor. So this would be the fruits of my toil. Unfortunately, we got a slight breeze blowing the steam the opposite way there. Every once in a while it picks up just a dab, but this is what we got going on. This is a infrared heater or infrared burner. So not all of our heat is lost flying out the stack. A lot of the fuel is combusted inside that combustor that gives us this powerful infrared heat effect. Over time, those coils will get a little carboned up a little bit and absorb heat a little better. I'm also going to take some black heat resistant spray paint and spray a little bit in there. We're running right about 80 psi, just under 80 psi of propane here. I haven't had time to weigh this. This is the maiden voyage. So I had to make two burners in this process because the first one did something unexpected. You can see the difference. The one on the left is the burner that I ended up with. This is the modified burner. It seems to be burning way better anyway. But the one on the right is the burner I started with, which appears hot enough and to be putting out a lot of power. But a very strange thing happened to it that made it unreliable. So, this was one of my first attempts, just trying out a couple of different things. This seemed to work really good, actually. Got a nice good fire coming out of that, but the whole plate isn't getting hot. There's some cold zones still. So the holes seem a little small to me. They need to be way smaller than this. We're not getting that internal combustion thrust. I think we need to go back to the drawing board on this one and cut some smaller holes and see how that does. Okay, so here's the improved design, changed a little bit. Got rid of this, and I made the holes smaller. I knew we could get more kick out of it. It has a lot more thrust to it now. Huge increase in performance. I think this snout's a little more aerodynamic than the one I had on there. So check this out, guys. I changed the hole size by that much. See that smaller hole inside the bigger oval? Now, overall, when I calculated the surface area, this inner black circle represents the new cross-sectional surface area of these ports. So we're now this big, and we was this big with these larger holes here. And this was the intake shroud that I've been using from my liquid burners. It seemed to do okay, but not on this one. Okay, here's the old one. And as you can see, it has much larger holes. I just didn't like the way it felt. It had a bad feel to it. Also, there's some inner turbulence here. It causes a blowtorch effect to pop off too strongly in the beginning. Pilot light. We'll see what happens here nonetheless. I was getting shot at. Already I can feel the power. I don't think the neighbors are into it. I accidentally had my nozzle crooked. Notice how that little bit of a turn shut it up a little bit. Okay, so I think I finally got this thing tuned. It likes this nozzle being crooked right here, or else we get a lot of reverberation going on. Alright guys, the max temp I was able to get was 243 degrees Fahrenheit. This thing is going to be treated. Water treatment system will be hooked up to this thing. I'm just kind of holding it in the stream, burning my hand off at the same time. So tomorrow I'll get some better numbers. You can see we were well above boiling there. But that's where we're at. This is just the first test. I haven't tried to turn up the power or nothing yet. Coming out of this thing is incredible. We could add another coil on top of it. So I'm going to tune that nozzle again and quiet down that burner and hook up all the temperature control gear, and we'll be all set for the temperature control test.